Hi, I'm Joe Todd, and today I want to show you a quick way that you can help young students overcome misconceptions they often have around thermal energy. To do this, we'll make use of software and sensors and combine that with a hands-on activity. This really engages students because they enjoy manipulating the equipment, but it also helps them to visualize this challenging concept. It also modernizes our instruction and really better reflects the types of technology that our students would be expected to work with in the future. All you will need for this activity is a light level sensor, a temperature sensor, dark food coloring, and water at different temperatures. Warm water and chilled water work well. Let's start with what younger students know about thermal energy. And that is that cold things feel cold, warm things feel warm, and hot things feel hot. But what is really happening to the molecules in substances that have different thermal energies? You could tell them that because they have more thermal energy, they're going to have more kinetic energy, but it'd be much more powerful to have students work with the sensors and discover this for themselves. Start by asking them this question: what kind of motion do molecules have in water when they're warm versus when they're cold? Give them a chance to discuss it and think about it, and then let them explore using the light level sensor and the temperature sensor. If your students have never used the light level sensor before or the temp sensor, it's a good idea to let them explore with them first so they have an idea about what they actually do. That will give them a much better idea about what the lab is actually showing them. This is cold water. As food color enters the water, we immediately see a drop in the light level because food color particles block some of the light. The rate at which they spread, though, depends on the thermal energy of the water. Now for the hot water. Again, we see an immediate drop in the light level with the introduction of food color. However, since hot water has more kinetic energy than cold water, we see that the rate that the food color spreads in the bottle is faster. Now we will compare the two water samples side by side to show how food color is dispersed at different rates. Students will notice that food color in cold water spreads less as it drops, and much of it reaches the bottom of the bottle. The hot water, in comparison, causes the food color to diffuse more quickly. Of course, the data from the light and the temp sensors will help to quantify this. Then it is a good idea to further help students understand the difference between the behaviors of the particles of the different temperatures by showing them a simulation, like this one here from PhET. Models like this are essential to help students visualize phenomena that they cannot directly observe. The connection is more powerfully made, however, when students have had an opportunity to have a hands-on experience with the concept. Thank you for watching, and if you have any questions or would like to contact me about middle school or elementary science, you can email me at k8@pasco.com. And be sure to check out our exciting new Key Concept series for life, earth, and physical science from Sally Ride Science. There are 90 labs that combine hands-on activities with technology to help students learn the big ideas in science.